Alright, hello everyone, my name is Manny, and I'm going to be showing you guys the design process of a two-layer PCB. Um, as you can see here, I have my schematic with a barrel jack connected to power and ground, an LED circuit, and some header pins that are tied to various resistors and capacitors with a 5-volt power tag and a G&D ref. So before we move on to PCB design, I kind of want to go over the net labeling situation. So here I have a line that's associated with this net label, and I named it LED. And it should correspond to this pin over here, in which I added another net label that's also called LED. And here I have another net. Here I have another net label that's called ADC output. And the reason I named that ADC output was because this net label gives it meaning, so you know that your ADC output would be associated with this line. It kind of makes it easier to track everything. At the end of the day, these are just names that you associated with the net labels, and I can show you how it kind of corresponds to PCB design. Here I have another node with a net label named apples. As you can see, doesn't really matter what you name it. I just chose to name it apples for example. You can name it something like maybe op amp output. If that node would be important to you in that way, you can name it op amp output, but apples would be just as fine as long as it has meaning to you. So let's go ahead and go over to the PCB editor. So you're going to hit this button here, and it's going to bring up this design window here. And you're going to want to play around with the configuration of each of these parts. And it's not going to be perfect the first time, so you're going to have to play around with these a bit. So let me go ahead and delete these guys. So first thing we want to do is create an edge cuts layer, which is a design outline. So we're going to go over to this tab here and look for edge cuts and select the rectangle shape, and we're going to draw an outline for this. Yeah, that looks good. Can kind of show you how it's going to look in 3D. Essentially what that rectangle that we just created was this outline here. Of course, if we would have made this bigger, it would have corresponded to a bigger design outline or design board. So yeah. Oh, actually, another thing I kind of want to mention is this barrel jack here. So the way I have it placed on this PCB design is looks like I have it backwards kind of. Power is usually inputted from this side of the board. So what I want to do is flip this footprint around entirely so that it's flipped, and I can connect power from this side without having to interfere with any of these resistors. So I'm going to go ahead and do that. Let's exit out of view. I'm going to select this pin, and I'm going to go to my keyboard and press R, and that goes ahead and flips the component around. If I go back to my 3D viewer, as you can see, we completely flipped this component around. Only thing we might want to fix is this reference designator. So I'm going to select that, hit R, probably move this over here. Reason I flipped it, because I wanted to be consistent with the other reference designators. So if we go back to our 3D viewer, there we go. Flipped it around and placed it over here. Okay, so now that we have established our design outline and we know that everything is in the right order, such as components, we can go ahead and do our ground layers or our layers. So I'm going to go ahead and start with the bottom copper and select this icon here that says add filled zone. And I'm going to go to the bottom left corner and click, and then you should open up this label here, and you want to associate a net to this copper pour. What I'm going to do is select GND ref, hit OK. Whoops. Start over. GND ref, and you want to go along the lines of this outline here. Cool. I'm going to go over to my keyboard and select the letter B, and it's going to automatically fill in that copper zone. Whoops. Get my laptop real quick. Okay. So essentially what these copper pores do is just add a zone that is copper associated with a certain net. So in this case, I chose GND ref. So any pins that are associated with that net are automatically going to be tied to that pore. So these are what are called thermal reliefs, are connected to this pin here, but as you can see, it's not connected to that pin because that doesn't have the net label GND ref. But this pin here is labeled GND ref, and so is this pin. But in this case, we have a surface mount component involved, and we don't have any thermal relief connections to this GND pad. Essentially because this is a two-layer board, and this component specifically is sitting on the top copper, not the bottom copper. So I'm going to go ahead and create a top copper for GND ref. So I'm going to hit front and then select add filled zone again, bottom left, and select GND ref. Okay. Create my shape for my copper pour. Okay, and then I want to hit the letter B, and it's automatically going to fill. Take note, as soon as I added my top copper port, now we establish a connection with that pad. Okay, kind of show you how that looks in 3D. Take a look here. This is the copper pad that's associated with this component, and it's going directly into that pad. Okay, cool. Now we can start routing all the other components. So I'm going to go ahead and start with 5 volts here. So to do that, we're going to hit this icon here that's labeled route tracks. Select this guy, and then we're going to start connecting the dots essentially. Keep in mind this is a power trace, so power traces need to be thicker than your data traces. So I'm going to go ahead and make these go to right click and hit properties, and we're going to change this to 40 mils. Cool. And depending on your design, you want to use a trace width calculator to calculate the trace width for these power traces. So if you're using 2 ounce copper or 1 ounce copper, it's going to change the width of these guys. But I would go based off of your max current rating. So if you're using a high torque motor and it requires a lot of current, obviously you're going to want to beef these guys up a bit more to account for that current draw. Okay, let's just continue routing. So these two nodes are connected, this pin and this pin. And the way I can tell is by this rat's tail here that shows a blue physical connection. So now we know that we need to connect those two components together. So I'm going to do this and this. Awesome. And we want to fix the length of the trace. So I'm gonna hold down Shift, go to Properties, and I'm gonna make this 15, and that's pretty standard for a data trace. Okay. Now I need to connect these two pins together. So there's two options here. I can start from here and go all the way around and back to this pin here, but I'm going to show you guys a different method. So these past two traces we've been on the top layer, but you can actually route things from the bottom layer as well. And if we go over to bottom copper and add track again, select this guy, as you can see the trace is now blue, associating it with the bottom copper. Awesome. So now we're gonna select this guy and edit the trace width. Back to the top, and let's finish routing everything else. Okay. One thing that you guys want to keep in mind when doing these trace editing is to avoid 90-degree angles, simply because they can cause latency, and overall it's just bad to have 90-degree angles inside your design. Properties, and let's make this 15. Okay, last thing we need to do is route this pin with this pad. So we have an interesting, so we need to tie this through hole pin with this pad. I'm gonna show you guys something real quick. So let's say I want to go ahead and go from the bottom this time and come in through here. And I'm going to try to connect this, but you can see that there's still a rat's tail here that's showing that there's no physical connection, but that's because I'm on the bottom layer and this is a top layer component. So in order to establish a connection, we need to place a via here that brings us back to the top layer. I'm going to place that here, and then add a trace again, and then go from this via, whoops, front copper. Yep. There we go. Now we've established a connection. Okay. I think that's all the physical connections. Next thing we need to do is run a DRC in order to get our clearances. So you're probably wondering, hey, if this is a ground copper pour and this is a 5 volt, what's causing it? What's keeping this trace from shorting with this copper? Well, we need to establish a clearance in between those traces. So what we can do is just run a DRC check, and it automatically establishes the clearances for each of the traces. And okay, now that we have everything routed, everything in place, I think we're ready to generate some Gerber files. So in order to do that, we're going to go ahead and go over to File, hit Plot. Actually, before we do that, I think it'll be good if we create a folder especially for our Gerber files. So I'm going to go on my desktop and hit New Folder. And I'm going to name this Gerber Gerber Zip 1. Hit File, Plot. Okay, and in this menu, here's where we want to select the layers for our Gerber file. Just please make sure that you have the front copper, bottom copper, front. Actually, we don't need paste layers. We want the silk screen, bottom silk screen, front mask, bottom mask, and the edge cuts. These are the layers that we're most worried about. Okay, and then we're going to want to select our output directory for the folder that we just created. In this case, it's Gerber Zip 1. Let's go to desktop and then look for Gerber Zip 1. Here it is. Select the folder. Yes, I want to change the relative path, and then just hit plot. Cool, now we created our Gerber files. We're going to want to generate some drill files for that as well. Make sure that this output directory is the same as this folder, and hit generate drill files. And yeah, we should be good. We can close out of this guy. We can minimize this, also minimize this, and minimize this. Here's our Gerber that we just created. We click into it. Just a bunch of files that are used by PCB manufacturers to generate copper pours for your design. So yeah, typically Gerbers are usually compressed into zip folders, so we can go ahead and do that. Generate the zip, and here's that corresponding zip folder. And what we want to do is go into JLC PCB. Here's a PCB that I designed earlier. I actually want to upload a new one. Okay, and it's pretty easy from here. Yeah, I would recommend creating an account with your MyASU Google. It's pretty easy. And then essentially you just grab your Gerber zipped and then drag it into this icon. And JLC does the rest from here. After it loads, essentially just going to show you how the design looks from a 2D perspective. Each of your footprints, both top and bottom. And yeah, for manufacturing this PCB, I recommend that you keep everything default. And yeah, that's essentially it. It's ready to be sent out. All you'd have to do is do like the payment and such. And yeah, that's essentially it. Thank you. Actually, one more thing that I wanted to mention about PCB design is the embedded systems. The embedded systems website. It's embeddedsystemsdesign.github.io, and this was actually created by Dan Aukes and Sean Jordan, who originally created all the assignments for this class. So yeah, they have pretty useful KiCad tutorials, and kind of show you the basic steps for creating a design schematic and also PCB design, how to export Gerber files. So yeah, everything is pretty much listed on this website here. And if there's like something else that I didn't go over in the video, um, there's a pretty high chance of it being documented somewhere here in this website. Yeah, I'd recommend using this website for PCB design on KiCad, and I think they even have some posts that go over PSOC as well. I can show you some of the examples they have listed out here. Adding background to your PCB kind of explains Gerber files for you. Design rules setup, a design tutorial. Oh, another important one about copper rub out. So I definitely check this out and add a copper rub out to your PCB, something I missed. Anyways, that's it. Thank you.